6.3 properties of parallelograms. We're moving through our polynomial unit. We have parallelograms, we have quadrilaterals, and then we have special quadrilaterals left. So we're just going to learn those properties and use them to find different parts. So a parallelogram, they have two sets of parallel sides. So, Noah, if I say AB is parallel to what? CD. Can you guys see the green okay?
Yeah.
Kale, AD is parallel to what?
BC.
Is BC. So their opposite sides are parallel. Bless you.
Thank you.
BD is a transversal. So all parallel line transversal properties apply. There are other transversals on there. So we have these two are parallel, yes? And I told you that BD was a transversal. Okay. Well, AB is a transversal of BC and AD, isn't it? Well, CD is also a transversal of BC and AD. But isn't BC a transversal of AB and DC? Like you have a lot of parallel lines and a lot of transversals, don't you? Okay, so what that means to us is we have alternate interior angles that are congruent. So these two are congruent. Well, another alternate interior angle would be these two. Well, that means I have angle, side, angle. Angle, side, angle. So it means these two triangles are congruent, correct? So what does it mean about angle A and angle C? They're also what? Congruent. Am I good? So, given the parallelogram WXYZ, what is YZ? And there's missing a line above there, yes? So, what is YZ?
3.26.
How did you know that, Kale?
It's parallel to X, W.
It is parallel, but that doesn't tell you that they're also congruent, yes? Okay. And what is WZ? Make sense?
Yeah.
Okay, so consecutive angles theorem. Consecutive angles mean right next to each other, there is one side that touches both angles, correct? Okay, if a quadrilateral is a parallelogram, so if it has four sides and it tells me it's a parallelogram because it has two sets of parallel sides, this applies. The consecutive angles are supplementary. Dakota, what does supplementary mean?
Something.
We've been using it since chapter 2, actually probably chapter 1, but chapter 2, section 1, definitely. What does supplementary mean?
Adds to 180.
It adds to 180. Also, if you looked on your notes, it says right there, doesn't it?
Where?
Right here. It's right on your notes. Okay, so AB, the sum is what?
180.
180. BC, what's the sum? 180. What's AD? 180. And what's CD? 180. So could that be helpful in the grand scheme of everything? Yep. It has four sides, so the sum of all the angles equals 360, correct? In our last picture, we know that A and C are congruent, yes? And we know B and D are congruent. So would that be easy once you have one angle to find all the rest? Yeah. Okay, bisector theorem. What does it mean to bisect, City?
To split something in half.
Okay, split something in two equal parts, right? So if a quadrilateral is a parallelogram, then the diagonals bisect each other. Now, it didn't say the diagonals were congruent, did it? It said they bisect each other. So that means that AX is congruent to AZ. And that means that AW is congruent to AY. It didn't say the diagonals were congruent, did it? Just that they are cut into equal parts. So with all this information that I've given you on the front, we're going to just find different parts of parallelograms. That's what we're doing today. Okay? Everyone good? Okay, the quadrilateral PQRS is a parallelogram. What is the value of X for all side lengths? So how are we going to do this?
Add all the common.
What do we know about opposite sides?
They're congruent.
They're congruent. So that means I can set those equations, what, to each other? Equal. So 7x minus 3 equals what?
Equals 2x plus 12.
Okay. And 4x equals?
X minus 3.
Okay, since they all have x's, do I have to solve both of those?
No.
No. But you solve one or both. I'm going to solve both, and we all better come out with the same answer, yes? So, go. Did you get x equals 3?
Yeah.
Yes. Okay. It didn't matter which one I solved, did it?
No.
Okay, so I'm going to highly suggest to you that you read all of your directions. It says, what is the value of x and what? All the sides. So on the test, the biggest mistake I get is people solve for x and stop. Is that all I wanted? No. I need to plug it in. So 4 times 3 is 12. So the opposite side better equal what?
12.
12. So that'd be 15 minus 3, which is what? 12. And then I would have 6 plus 12, which is 18. Am I going too fast?
No.
And then I would have 21 minus 3, which is 18. Again, I'd only need to plug it into one and be the same as the other, right? But this way checks it. Everyone good with that?
Yep.
Okay, the next one. Given the parallelogram ABCD, what are the measure of angle A, angle B, and angle C? Regan, got an idea what we could do? Look at your rules from the other page. One that applies to angles.
Add to 180.
What rule applies to the... Yeah, the consecutive angle theorem. So that means that A plus D equals what? 180. So if I take 180 minus 114, it's 66. So 66 is A. What's B?
114.
114.
Because they're congruent.
Because A and D are congruent, right?
C is 66.
And C is 66 because A and C are congruent. So we could have found C first, right?
Yeah.
Okay. Questions?
No.
We've done all the stuff, right?
Yeah.
Just different ways. Now what? Given the parallelogram GHJK, what is the value of A? And what is the measure of GHJ and K? You guys want to try this one on your own?
Yes.
Okay. You're going to use your consecutive angles theorem. Addie, what do those two angles add up to be? Can I start?
Mm-hmm.
Do I have to write all of them down?
Hmm?
Do I have to write every single one of them down?
Yeah, because it says to. Okay, did you get A was 20?
Yes.
Yes? And how do I find that? You said no, Kale?
Yeah, I didn't get it first.
Either.
Okay. What happened? Did you add
I
the...
added the 5.
You added the 5s and got 10, right? Is that what you did, Amber? Yeah. I wanted to do that right at first, too. But one's positive, one's negative, so they zero out. And you showing me your work, guys, is going to, it's going to show me that you knew what you're supposed to do. So they equal 180, so A is 20. And then we plug 20 in. So 20 plus 5 is 25. Now, could I just take 180 minus 25?
Yeah.
Yeah, but putting it into the formula, so I got 20 times 8 is 160, minus 5 is 155, and 155 plus 25 is
180.
180. So are there lots of checks there for me?
Yeah.
Yep. Questions on that, guys?
No.
Oh, this missing lines of this K and that. You guys put those KS or SK and RT. Okay, given the parallelogram RSTU, with SU being 35 and KT being 19, what is SK and RT? Well, what do we know about the diagonals? What do they do to each other?
They bisect.
Bisect. So I know KR is congruent to KT.
Yeah.
And I know KS is congruent to KU. So how can SU help me find SK? Should be KS, shouldn't it?
You should divide SU by 2.
I should divide, so KS equals half of the diagonal, doesn't it? So 2 goes into 3 once, carry a 1, and 2 goes into 15, 7 and a half. Okay. So I know KT is 19
Times it by 2.
times it by 2 because both of those are equal. So RT equals 2 times 19, which is 38. Not that hard, is it?
No.
Pretty
No.
hard.
Okay. Ooh, the next one should be fun. I want you to try the next one on your own. Given the parallelogram GHJK, if PK equals 4 and HK equals 2/3 of GK, what is GP? So go through and identify what are congruent on your picture. Would be the helpful start. Amber, put what you know on your picture.
Huh?
Put what you know on your picture. Where's PK go? What is PK? 4. So on PK, put a 4. So what does that tell me that HP is? So then it tells me right here that HK is 2/3 GJ, and the GJ is missing a line. So what is HK? If the two pieces are 4, what are they together? 8. So I know 8 equals 2/3 GJ. Because we're just replacing that. That makes sense? Okay, so you got, I'm going to rewrite it. It told me that PK was 4. And the bisector theorem tells me that HP and PK are the same. So that's HK is the whole thing. So each part's 4, so the whole thing is 8. So I just replaced 8 with the HK. So I have 8 equals 2/3 GJ. So how do I move the 2/3 to the other side? Multiply by 3 over 2. And this is 8 over 1. So 2 goes into 8 how many times? 4. And 3 times 4 is 12. So GJ, that's missing a line above it up here, make sure you put it there, is what? 12. Oh, and then what is GP?
6.
So the whole thing is 12, so GP is
6.
6, because it's half, right? So will it help you to maybe draw a picture and write stuff on it? Yeah, doesn't have to be perfect. We're not selling any art here. Questions, guys? Use those formulas on that first page, those theorems, okay?
Or can I get to work?
Yes, please get to work.